Hi guys, today we are going to start our new chapter on polynomials. And so we're going to start with a little bit of new vocabulary. There's some terms here that maybe you've heard of before and maybe you have not. But our first one is the word monomial. A monomial really is just one term. So for example, 4x squared y, that would be a monomial because it's just one term connected only using multiplication. There's not any addition or subtraction signs in there. A binomial, maybe we know that root or that prefix bi means two. So a binomial is two terms connected by a plus or minus sign, such as 2x minus 4. That would be an example of a binomial, two terms connected by a subtraction sign. A trinomial, that root tri meaning 3, so trinomial is 3 terms connected by addition or subtraction signs, such as, for example, 2x squared plus 4x minus 8. So that would be an example of a trinomial. And a polynomial is kind of a more generic term, just meaning several terms or multiple terms connected using those addition or subtraction signs. So a trinomial could be considered a type of polynomial, or a polynomial could have 4 or 5 or more terms also. So polynomial is a little bit more generic there of a term. And the next thing we're going to look at is how to find the degree of monomials and polynomials. So the degree of a polynomial is equal to the sum of the exponents on the term with the highest exponent sum. And that might sound complicated, but I think once we look at a couple of these, you're going to realize this is actually pretty easy. When we have a monomial, like this first one, A, that's a monomial, just one term, 3x squared y, all we need to do is add up our exponents. And we're only talking about our variables here. So that 3, that's like an exponent of 0 on that 3 because it's just a constant number. So we don't have to count an exponent there. On this x, we have an exponent of 2. And remember, on any variable that there's no exponent listed, that's like having a 1. So on that y, that's like having an exponent of 1. So our sum of the exponents here would be a 2 on the x plus a 1 on the y. And so our degree there for that first one is 3. Here on this next one down here, again, we're just adding up those exponents. So we have kind of a 1 there on this x, but that 4 is a constant, so there's no other exponents there to be adding together. So really our degree here is just 1. If you go up here and look at this next one, this one is a little bit trickier. So this is a binomial. We have two different terms. And so the sum, if we look back at what we just wrote, the degree is going to be equal to the sum of the exponents on the term with the highest exponent sum. So I'm not going to add both terms together. I'm going to look at them separately. So when I start here, looking at this 3x squared y, that has a degree of 3. This 5x cubed y cubed, we add the 3 from the x and the 3 from the y, that has an exponent sum of 6. And we said the degree is equal to the sum of the exponents on the term with the highest exponent sum. Well, 6 is greater than 3. Therefore, the degree on this term is 6. Okay, so that 6 is the highest term, making the overall degree 6. And our last one here, all we have is 4. And like we just said before, if there is just a constant, then we don't have to count any exponents there. There aren't any exponents, or the exponent would be like a 0, and therefore our degree here is 0. All right, we are going to go ahead and move on now, and we're going to actually start simplifying some polynomials. And so the first thing we're going to look at is the addition of polynomials, adding some polynomials together. And so we've got this problem here. It says a researcher studied the number of overnight stays in the U.S. national parks over a 5-year period. The results in thousands are modeled by the polynomials below. So we can see that in what they're calling the back country, there were 21x squared minus 140x plus 1900 stays. And in campgrounds, it was negative 7.1x squared minus 180x plus 5800. And so it's telling us in each polynomial, x equals 0 corresponds to the first year in a 5-year study. What polynomial models the total number of backcountry and campground stays during the 5-year period? So that key here is that we're being asked for the total. We know that total means we're adding together. So really what we need to do is we need to add these two polynomials that we were given together to find the total. So I'm going to go ahead and set this up just like an addition problem. So I have 21x squared minus 140x plus 1900. And I am adding now to that negative 7.1x squared minus 180x plus 5800. And so make sure that just like I did here, just like you do in any addition problem, you're lining up your like terms, right? I have my x squareds lined up, my x's lined up, and my constants lined up. And now we can go ahead and we can actually add these together. So I'm going to start down here with those x squared. So I have 21x squared plus negative 7.1x squared. So remember, this is just combining like terms. We don't have to do anything fancy with those exponents. We're keeping those exponents the same. So we're talking about adding like terms. So I'm really just adding those coefficients. 21 plus negative 7.1 is going to be 13.9x squared. So like I said, those are like terms. You're just keeping that x squared, combining like terms. Then we have negative 140x plus negative 180x. Well, negative 140 plus negative 180 is negative 320. And we're going to keep that x there. And then we have 1900 plus 5800, which is 7700. So here, that is our answer. Our answer is 13.9x squared minus 320x plus 7700. All right. Now let's take a look at a subtraction problem. So very similar here. We're going to start by lining it up as a subtraction problem. So I have x cubed minus 3x squared plus 5x. And so I'm going to go ahead and put that kind of on the top of my problem. And I'm subtracting this other trinomial from that. So subtracting 7x cubed plus 5x squared minus 12. And so here you can see in the first trinomial, we have a term with x's, right? And in the second trinomial, we don't. We do not have a term with just x's. So I'm going to go ahead and I'm going to put a placeholder in here. I'm going to say plus 0x because this second problem didn't have any terms with just x's in it. But I do have a minus 12. And if you like, here in the top, you can also put a placeholder for constants. You can see we don't have any constants in this first trinomial, but I could go ahead and I could just say plus 0. That's the same as having no constants. Okay, so I'm subtracting there, and I've kind of filled in anywhere where I don't have like terms. I've filled in zeros as placeholders just to be extra careful that I'm not combining terms that are not like terms. Now we can go ahead and we can subtract. So I have x cubed, really that's the same as 1x cubed, right? So 1 minus 7 is negative 6. x cubed. Then we have negative 3x squared. Remember, we always keep that sign that is in front of a term. So that's a negative 3x squared minus 5x squared. So negative 3 minus 5 is going to be negative 8x squared. Then I have 5x minus nothing, minus 0x. So that's just going to be plus 5x. And lastly, I have 0 minus, this is a subtraction problem, so minus negative 12. That double negative there, minus a negative, that's going to leave me here with a plus 12. 0 minus negative 12 is positive 12. All right, so that is our answer, negative 6x cubed minus 8x squared plus 5x plus 12. The very last thing we're going to look at here is multiplying a monomial and a trinomial. So really, hopefully we know now, monomial means one term. So our monomial here is this negative x cubed. And we're multiplying it times this trinomial inside the parentheses 9x to the 4th minus 2x cubed plus 7. Here, those exponent rules that we learned in our last chapter are going to be really important. We have to remember our product rule because we're going to be multiplying exponents, multiplying powers. Otherwise, we're really just using our distributive property here, right? So really, I'm just distributing negative x cubed times everything inside the parentheses. So I can go ahead and start here with this first term, negative x cubed times 9x to the 4th. Well, when I do that, I'm really multiplying the coefficients, right? So that's like a negative 1 times 9. That would be negative 9. And then I'm multiplying the variables, x cubed times x to the 4th. This is where those exponent rules are going to come in important. We're going to keep our base the same, so our base stays x, and we're adding our exponents. 3 plus 4 is 7. So negative x cubed times 9x to the 4th is negative 9x to the 7th. Then we're going to go ahead and we're going to multiply times this second term. So when I go to multiply those coefficients, this is a negative 1 times a negative 2. Well, that's going to leave me plus 2, right? Multiplying two negatives makes a positive. And then the same thing with those variables. We're going to keep our base and add the exponent. So 3 plus 3 is 6. For this last one, let's go ahead and multiply there. We're going to multiply the coefficients. So that means 7 times negative 1. That's going to be minus 7. And here on this last term, we don't have any x's to combine. So we just have those original 3 x's from our monomial out front, so 7x cubed. So that's our answer there. We multiplied that monomial and trinomial, and we got negative 9x to the 7th power plus 2x to the 6th minus 7x cubed. One thing you might have noticed as we went through this problem is that we always kept our exponents in decreasing order when we wrote our trinomials or our polynomials. That's something that you might have noticed in each of our examples today, that our exponents are always descending through the expression, right? We start with the highest one and work our way down. That's kind of like the standard way to write polynomials. If you are not in the habit of doing that, let's go ahead and get in that habit here for this chapter of writing our biggest exponents first and decreasing then as we read left to right. All right, the last thing I need you guys to do here in your notes is try these last two problems. So you have one problem here that is going to be either addition or subtraction. After you read the problem, I think you'll be able to figure out what to do there. And then you have one more that's multiplying a monomial times a trinomial, just to get you a little bit of practice there. So make sure that you have included all of the examples in your notes, that you have those key terms from the beginning of the video, and that you try these last two problems. If you guys have any questions while you're going through these notes or while you're working on the short homework assignment for tonight, go ahead and just send me a message. I will be available on email and Canvas messages during normal school hours today until 3 o'clock.